Yeah, the title that was given to me is Energy Transition Business and Technology Trends in Malaysia. I took up the word Malaysia because I think there isn't enough story to tell yet regarding flexibility or things that we are doing. But I'm going to show by maybe some technologies that may support transition and the technology trends, especially flexibility that we are looking at in TMB in general. So my name again is Aznan Ezra'i Arifin. I'm the strategy officer here in TMB Research. We are part of Tenaga Nasional Berhad Strategy and Ventures Division. So that is our building here in Bangi, Selangor. So it looks like an aircraft hangar. So you are all welcome to come and see us. Okay, so context. Let me set the context and objectives of my talk. So we know that energy transition is a pathway towards transformation of the global energy sector from fossil-based energy production and consumption to zero carbon. That is made possible, among others, by advancement in energy sector. So in Peninsular Malaysia, the renewable energy capacity mix is projected to achieve 31% by 2025 to meet the RE capacity of 40% by 2035, which is dominated mainly by solar. So 31% is a huge number for us. As you all know, these are it is variable and intermittent. So you cannot replace 1 megawatt of coal with 1 megawatt of solar, obviously. You probably have to do 7 or 8 times that just to get the same capacity because of the low load factor. So that's a challenge for us. But this is a commitment that we made, and probably I didn't mention today here that Malaysia has made a commitment of a certain reduction, 35% reduction in carbon intensity by 2035. So we had our minister went to I think was it Glasgow, right? And to actually commit Malaysia's intention to be carbon net zero by 2050. So all of us in the industry has to contribute, especially we all know that the energy sector is one of the most polluting industries in anywhere in the world, as Malaysia #1. So we have to make that, we have to contribute to that ambition. So with the penetration of grid-connected variable energy, it is necessary for TMB to facilitate this energy transition in Malaysia. So we have to facilitate this transition of energy transition to ensure, but while at the same time ensuring resilient and reliable grid that can withstand disruptions and unanticipated system failures. Therefore, it is important. So in order to have this energy transition, we are focusing on providing power system flexibility to be a catalyst in realizing the energy transition to achieve a Malaysia net zero goal. So what I have here on the right hand side is the objective of my talk is to show you, to share some innovation in energy transition in TMB's perspective, and to demonstrate the development of power system tools that we have in the building behind me to increase flexibility in TMB and TMB Research. So that's a simple chart that I probably share regarding some renewable energy targets that we have now in Malaysia. We still have way to go. So that's the content of my talk. So as usual, what we call in Malaysia pesanan penaja, I have to tell you what we are. So we have to take the opportunity to introduce ourselves. So TMB Research is sorry, I cannot, I cannot see the top part of it. So we are one of the leading and largest R&D company in Malaysia. We are a subsidiary of TMB since '93. We are not a profit-driven center for electricity. We specialize in energy and environmental sector. And we are we say trusted R&D company because of the things that we have done for the last nearly 30 years. So this is our people, the number of people we have, and the services that we are doing are we are dividing ourselves. We have divided ourselves into applied research and advanced research. So the one on the applied research, we cover areas such as power delivery, power generation, environmental management, strategic research. And on the right-hand side is advanced research. We have a focus group on low carbon power generation technology, emission waste management technology, smart grid, and green technology. So this is we can share these slides later. This is some of the sub areas that we're doing. We are focusing on things that we all know that most of us here are also doing the same thing: electric mobility, energy storage, smart city, digitalization, decarbonization. We have from our mother company, focus group on future generation, grid of the future, and sorry, I always have this problem with Zoom because I cannot seem to move. Future-proof regulation. The services that we offer are things like non-destructive tests, product inspection certification, and NTP. Sorry. Trying to move the, okay, managed to minimize. I'm sorry, I'm not quite familiar with Zoom. So, okay, let me start my, the beef of the talk by saying that TMB's aspiration is to achieve net zero emission and be coal-free by 2050. Our commitment is 35% reduction in emission intensity, halving our coal capacity by 2035. So coal is maybe 50% of our generation capacity now. To reduce that 35% is probably you have to do about maybe 3,000 megawatts of reduction in coal. So that's a big ambition that we have set onto ourselves. We believe that so we were going to have a target of 8.3 gigawatts by 2035. Our commitment of 35% reduction of our emission intensity by 2035, aspire to achieve net zero emission by 2050. So it's not just we are targeting, setting ourselves a target by 2050, but we have milestones. So we have by 2025, we have a renewable energy target of 8,300 megawatts. By 2035, we had a certain reduction of emission intensity and reduction of coal capacity. So of course, when you talk about our other contributions, these are our contributions. It's not just on the electricity business. I'm not going to talk about this, but we on one of the topic which is shall I say very hot in Malaysia now is regarding ESG. So we have to show this. This is our other than electricity business. These are the things that we do for the society in Malaysia. So we have come up with this sustainability pathway 2050. The target is, number one is the one that I mentioned before, and the second one is to achieve zero fatalities by LTIF below 1.0. And then we have committed to spend 1% of our profit towards environmental and community-related programs. So our strategic pillars will be three. We are investing in low emission and green technologies. We will evolve the grid and grow more renewables. And we are going to unlock new energy revenue streams. So by doing that, we will benefit our customers on the existing business. In the generation side, we will maximize our potential on existing assets. Then we work on hydrogen and green fuel alternatives. We're going to develop many small hydros, and then we are looking actively into carbon capture and utilization. Grid of the future, smart utility, battery energy storage. I don't want to go into that. We all know what they are. We also are doing that. Internationally, I would like to mention that we are expanding our wind capacity in UK. We have a battery energy storage system that we also are evaluating in European countries, expand our solar capacity. We are seeking emerging green technologies such as hydrogen, CCU, and waste to energy. And our retail side are also actively looking again at battery storage also behind the meter. We have a subsidiary looking into putting a charging stations, and we are doing beyond meter solar. And of course, we also have a program on energy efficiency. So let me go into, okay. So the title is energy transition. And I think it is important that, why we do energy transition, because we want to contribute to the environment. So how to enable energy transition? That's the word for flexibility. So the one maybe some of the speakers have mentioned before, what is flexibility? I'm not going to again redefine, but I'm just going to show you from our perspective is that this energy trends has caused variable energy uptake that increased rapidly in recent years because of steep cost reductions, innovation, and policy support. So this increase in renewable energy gives challenges to balancing the power system while maintaining security, reliability. So to address these trends, we need to find new ways to increase grid system flexibility. We require innovation in the way policymakers, regulators, utilities plan to manage and operate the system. So this flexibility is to manage very high renewable energy that we have put ourselves a target on. So a more flexible grid will ensure that the power system with a large share of renewable energy can be operated reliably and cost effectively. Increasing flexibility can come from both the supply side and the demand side. So what are the benefits of flexibility? It opens up an opportunity to integrate a larger quantities of renewable energy while maintaining electricity and supply reliability. And then it also drives electricity decarbonization and help transform the whole energy sector. So, okay, so this one I've taken from Irina, maybe some of us have seen it. Power system flexibility is an enabler in energy sector. So power system stability are coming from distribution, generation, transmission by interconnection, storage, demand side, and then we have also sector coupling, power to heat, power to gas and electric vehicle, then can provide flexibility in energy sector. So to respond to both expected and unexpected changes in demand and supply, the balancing of supply and demand at all times is crucial for system reliable operation, since even a small mismatch can disturb power system frequency and possibly affect reliability, as we all know. Flexibility has to harness all sectors of the energy system, from stronger transmission system, distribution system, and all the way to having a flexible demand on demand side management and sector coupling, especially if you have power to heat or power to gas industries.
Yeah, 3 minutes to go, Arshad.
Sorry?
3 minutes to go, yeah.
3 minutes, okay. So the impact of variable energy at various time scales are listed here. Okay, what are the technical measures to increase system flexibility? We have supply side flexibility, demand side flexibility, again, energy storage, grid flexibility. And the one I've shown here is challenges in energy transition in summary is from a generator dominated system into an inverter dominated system. So before I finish, okay, let me show you a few technologies that we're working on. There are some slides at the beginning is to have a strong, flexible, and intelligent grid. Of course, to enable flexibility, you have the one, again, I re-emphasize that you need to have interconnection between the region. We have interconnection with Thailand and Singapore. We're working on demand side management. We have FACS devices as, in the grid, and then we are working on new controllable load. So these are some of the resources for flexibility that we're looking at. Okay, but the rest of the slides, okay, we will share the slides later, is that in TMB Research itself, we are working on wide area intelligence system framework, or wide area intelligence system based protection system, WISE-based monitoring system, WISE-based control automation system. We have a grid digitization framework that we all listed here. For the interest of time, I'm not going to go through it. And then we have real-time power system analytics framework. So we believe all these tools will help us to check on the flexibility of the system, and all of these are developed in-house. So we also have a technology called coordinated voltage control system architecture. Obviously, when you have flexibility and you have renewable energy more into the system, you need to have a better control of voltage. We have a control voltage, coordinated voltage control system architecture. And finally, something that we are proud of in TMB Research is we have real-time hardware in the loop simulator to emulate large system network with advanced grid components and what we call digital twin platform, pairing virtual and physical environment. And we are here to improve critical process cycle times to drive innovation and performance, because we need to understand system requirements and develop enhancement to existing system. I think that's all. I think my brief sharing from what's happening in Malaysia, and then also the technology that we are working at in TMB Research to assist flexibility, therefore enable this energy transition. Thank you.